Hello guys, I'm E.D.I.T.H and today we're going to talk about conics a little bit. So specifically, we would like to talk about parabola, I would say. So it's kind of interesting. So let's just select the pen. Okay, there it is. So we would like to talk about parabola. So what is actually parabola? So it's a geometrical shape that basically looks like this. So I don't want to make things complicated, just the basics. So that's a Cartesian coordinate. So basically the parabola, it looks like this. So what is the significance of this shape? For example, the trajectory. That means if this is a building and you from this place you throw a ball that would fall like this shape is parabolic, right? So that's the significance. So there are certain important terminologies that we need to understand parabola. So I want to just talk about them in short. For example, there's a term that is called eccentricity, right, expressed with E. So for parabola, eccentricity is 1, right? So we have to remember that. So what is basically eccentricity? So okay, before eccentricity there are certain more. Before understanding eccentricity, we would like to go to the topics that we have to learn to understand eccentricity. So those are focus point, directrix. So what is the focus point of parabola and what is directrix actually? So the focus, like you guys must have seen a circle. So we know that there is a center point of a circle, but you're seeing that in this parabola there is basically it's not a filled thing, so you cannot find out a center inside it, right? So there is a point that for example, that can be the centroid of the parabola, right? So this point might be in this place. That is basically giving the proxy of the center. So that's what we call centroid. So this is the apex, and this is focus, right? So the distance from apex to focus, this distance is A. So how do you write that? It's kind of being messy. Okay, so that's A. So it's a constant value and we write it with A. And why A? Because for a standard parabola the equation is 4 y square is equals to 4ax. So okay, so what is directrix then? I'm keeping this equation here, okay, here, because we would like to talk about this later on again, right? Okay, what is directrix? So we have seen that from this apex, if we go A, like positive A, from the perspective of apex, you can say the right side we get focus point, but if we go the opposite side of the focus point equals to A, we get the directrix. So that is directrix. So why is this necessary to understand the eccentricity? So for the basics of eccentricity, from the focus point, if you take a random point on parabola and draw a straight line and connect them, and then if you, okay, so I have to increase that. If you, for example, if the focus is S and if the random point is P, and if you connect P with the directrix like this, and if you call that, what do we call that, M, then SP should be equal to, okay, then E should be equal to SP divided by PM. So that is eccentricity, the ratio of the distance from the focus point to a random point of the parabolic locus, and from that point the parallel line. So this line, this distance, it should be parallel to the axis of parabola. This ratio is called eccentricity, and for parabola specifically, eccentricity is 1. So it might vary for other geometric shapes like ellipse, hyperbola, but for parabola it is 1. So yeah, that's what eccentricity is. There are certain more things in parabola. For example, if you draw a perpendicular line going through the focus and connecting both the parts, the upper part of the axis and lower part of the parabolic axis, what you get is this is called the latus rectum. So this is latus rectum. I hope the spelling is correct. Okay, yeah, and this distance is equals to A. Okay, so what is the value of latus rectum? Latus rectum is equals to 4A. So that's the very first basics of parabola. So there are many things, many more things to explore here. For example, what if it's not a standard parabola? What if the focus point, sorry, what if the apex point is not the Cartesian center? So it would vary. That's why I put this equation aside, because this equation is true. This equation is true when apex is equals to 0, 0. But if apex is equals to alpha, beta, equation stands like this: y minus alpha whole square is equals to 4a into x minus alpha. So you have noticed one thing, that here is square and there is nothing, like the power is 1. So what is the significance of this thing? So there can be certain types of parabola. For example, there can be this, again there can be this as well, and also there can be this as well, being the parabolic axis and this being the directrix. So this is complex parabola. Not gonna talk about this right now, but these two parabola, this comes from the standard shapes. So we see that the apex coincides with the Cartesian center, Cartesian origin, 0, 0. So alpha beta equals to 0, 0. But for this case, the equation is y square is equal to 4ax, and for this case the equation is x square is equal to 4ay. So when the y has the power of 1, the parabola goes with y-axis. When the power of x is equals to 1, the parabola propagates through x-axis. That's a shortcut you can remember. What if it was to go like this? the equation would have been simply like this. Yeah, so that's the basics of parabola. I hope you have understand those things. I know it was a very scattered session, so if you like this, I can make more videos on this. So goodbye, and wish E.D.I.T.H luck for the next videos. Stay tuned. Goodbye.